So we are learning what? SFD, BMD, Shear Force Diagram and Bending Moment Diagram. So like quickly let us do some quick answers from your side. Give me quick answers. What is SFD and BMD? एकाने उभं राहून क्लिअरली आन्सर सांगा. वी वॉन्ट क्लॅरिटी नॉट किओस. हां हां झालं. दॅट इज द पॉवर ऑफ यू इन क्राऊड. सांगा पटकन. उभं राहून क्लिअरली यू हॅव टू फर्स्ट मेक द अपीअरन्स, डिस्टिंक्टिव्ह अपीअरन्स, देन पुट एश. काय चाललं तुमचं? बोलतोय ना मी काहीतरी. काय सांगतोय? महत्त्वाचा धडा सांगतोय. गर्दीतून कुणावरही कमेंट करणं, रिमार्क करणं फार अवघड आहे. सोपं आहे. Sometimes I waste my tongue as well. You have to get out of the crowd and put your opinion in front of the others. That's why I asked you to stand up. गर्दीत बडबडायचं नाही. आता एकाला उत्तर द्या म्हटल्यानंतर ऑल ऑफ यू शट युअर माउथ. ओव्हर राहून सांगायला काय जातंय? हां सांग. व्हॉट इज एसएफडी?
शिअर फोर्स डायग्राम आणि बेंडिंग मोमेंट.
काय?
शिअर फोर्स डायग्राम मध्ये इंटरनल फोर्सेस इंटरनल फोर्स काय असते, वर्टिकल इंटरनल फोर्सेस.
आता बडबडत होतं ना सगळे एसएफडी एसएफडी काय का सांगा ना. आता कोण सांगते? तू सांग बा. हां नाही राह तू नाही. हाऊ विच फोर्स? कुठला इंटरनल फोर्स? मग हां आणि एनिबडी वॉन्ट्स टू टेल? सांग. एसएफडी बीएमडी काय आहे? क्लिअरली कॅन यू स्टेट क्लिअरली? हां. प्लॉटिंग shear force along the length of the beam. So basically SFD and BMD is what? They are the variations. How the shear force or bending moment is varying along the length of the beam. Because currently we are learning the topic of beam. So SFD and BMD can also be drawn for a column. It can also be drawn for a beam column frame. It can also be drawn for a arch. It can also be drawn for a truss. Atta apan currently we are learning SFD and BMD for the beam. That to determine. That is what I told someone that I have to. Right now, what is the name of the topic?
Determinate.
What is the name of the topic? Read kara. Internal forces in determinate beam. Structures पर नहीं. So write down. Note करा. Write down the note. Write that. In the note, we are making a simple difference between these two types of structures. You all ना तुमचं बरेचसे ट्रेड्स आय एम ऑब्झर्विंग. समटाइम्स यू जस्ट blindfold yourself and just want to follow through. आता somebody showed me the last one yesterday only. Somebody put the photograph of mechanical drawing hall. There was this beam bolted at both the ends, and he himself, Vishwajit, he was saying that sir, this beam is not, the supports are not hinged or roller. Now you identify yourself. Then why don't you go one step ahead and see that why can't you solve that beam? I can't solve that beam. That beam is this. See, look at this one. म्हणजे मला छाती दुखायला लागले. आय एम ऑलरेडी टेलिंग यू. जर शिकवताना पडलो तर घेऊन जावा. आय डोंट नो व्हॉट इज हॅपनिंग. सो दिस इज हाँ, see, look at this. This is the simply supported beam A, B, and the right one is कुठल्या टाईपची बीम आहे? ही घेतलं ना आपण. ही टाईपची बीम लिहिली नाही. What is this type of beam?
Fixed ended.
Fixed, huh? Fixed ended नाही, fixed beam. It is a fixed beam. So this is simply supported beam, and this one is fixed beam. Now, the title of this topic says that the internal forces in determinate beams. That is what it says. Now we are looking at what is the determinate and what is indeterminate. Now tell me, what type of supports are there in simply supported beam? A ला कुठल्या टाइपचा सपोर्ट आहे?
Horizontal and vertical.
Support कुठल्या टाइपचा आहे? B. So how many reactions are there? BA and HA. And कुठल्या टाइपचा सपोर्ट आहे? B. Roller. So reactions B. Okay. What type of support is supports A? Fixed. How many reactions are there? BA, HA आणि कुठला? Moment. MA. What type of support is B?
Fixed.
Fixed. How many reactions? 3. BB, HB, MB. Yes or no? Now both of them are a particular type of a force system. If I indicate that this is x axis, this is y axis, tell me what type of force system these two are?
Coplanar.
Coplanar and non-concurrent force system. Yes or no? So how many equations of equilibrium are useful to analyze this particular beam? किती आहे? Equations कुठले आहेत? 3. कुठले? Summation fx is equals to 0. This you can use. What is another? Summation fy is equals to 0. You can use this. This is applicable over here. Ani?
Summation MZ.
And summation
MZ.
Summation mz is equals to 0. So how many equations you have? So number of equations is equals to 3. Very much important. Now look at this beam. How many unknowns are there? How many unknowns are there? How many unknown reactions are there? किती आहेत? किती आहेत? 3 unknowns आहेत की नाही? BA, HA and B. 3 unknowns. Now look at this. How many unknowns are there? How many unknowns are there? 6. Do you see this? Do you see this? I have only 3 equations, but here I have 3 unknowns. In this beam, I have 6 unknowns. Can you find out these 3 unknowns using these 3 equations? Yes or no? That is why these beams are called as determinate beam. काय म्हटलं याला? That is why this beam is determinate. Why? Because number of unknowns is equals to number of equations. Here, if you look at this, there are 6 unknowns and equations are 3. Can you solve this problem completely? Can you solve this problem completely by finding out all the 6 reactions using 3 equations?
No.
Solve करू शकता का?
No.
नाही ना. That is why this structure is called as indeterminate structure. Indeterminate structure. And why it is called as indeterminate? Number of unknowns is more than number of equilibrium equations available. That is why we can't solve this. And currently the topic is internal forces of determinate beams. Not this. This you will learn in structural analysis. Got this? Got this? चला, कालचा प्रॉब्लेम कुठला होता? UVL, SFD काढलेले, BMD ड्रॉ केलेले. You have drawn SFD, BMD?
BMD.
Okay. चला सांगा. Let us go quickly through the problem of UVL. सांगा काय? फास्ट सांगा रे. काय प्रॉब्लेम आहे? What type of beam it is? Simply supported beam A by no. And I have seen your notebook. बरेच जण, many people are missing out on a simple things like mentioning the degree of the curve, like mentioning the values at the different points of shear force and bending moment, like mentioning the length, the distance of the point from the supports, like mentioning the positive negative signs. So क्या होता है, you are not following me clearly. That problem is lying with your focus. See, I am going step wise. So first I have taken the projection, then I have drawn the beam. I am completing every detail which you miss out. So I have shown first left side support is a hinge, other it is roller. This is A, this is B. नावं सुद्धा दिलेलं नाहीये. Many people in the notes have forgot of the names. There is no name in your beam and you are writing shear force at A. Where is A point? How will I know where is your A point? It's चालणार नाही. That is why follow through whatever I am telling you and mention it in your notebook. So, कसा दिला होता इकडे? Maximum होता load? So this was the maximum load. Yes or no?
Yes.
And what type of load it is? What type of load it is?
UVL.
Uniformly varying load. आता कोणतरी प्रेम आला होता माझ्याकडे. So I explained this SFD and BMD to him again. Sometimes you'll have to spend separate time. In the class, I may not be able to explain it to you in your language. इथं मला common language use करावं लागते, whichever I speak. If you want me to explain it in your language, you come and meet me in person. आता बऱ्याच जणांना whenever I teach, ते समजत नाही. मग I told him, and I hope he understood. नसेल तर काय, but you have lot of time, but you have to give the attempts. Okay? So he UVL आहे, uniformly varying load. Somebody also asked me, त्यानेच बोलते काय, UVL चा टोटल लोड सर एरिया का घेतो? हे तुम्ही जे डाउट्स नाही म्हणता ना, वरद ना, वेदांत, you say you don't get doubts. Why if I ask you to calculate the total load, तुम्ही काय करता? You take the area of this triangle. No, why area? कधी विचार केला? मी सांगतोय, this is the truth fact, but I did not explain it beyond that. I told you it is the area of loading diagram. Loading diagram आहे, but why area?
Dimension
आणि you say sir, 3च डाउट्स आहेत. मला डाउट्सच आले नाही. काही जण म्हणतात सर डाउट्स रिझॉल्व झाले. काही जण म्हणतात की सर डाउट्स येतच नाही. क्यों? काय बघायचं रिझन? बघा, दिस इज डायव्हर्जन, बट यू से यू डोंट गेट डाउट्स, यू डोंट थिंक. हे असं मेन्शन करा क्लिअर, आय डोंट थिंक. That is the reason you don't get. So हे काय केलं बघा, UVL, this is L. दाखवलेलं आहे का? Then show the axis X, Y. This is what? Given beam. हे सुद्धा लिहिलेलं नाही काही जणांनी. SFD, BMD हे लिहिलेलं नाही आहे. केलं सगळं कवर इथं AB, UVL दाखवलं. What is the FBD of this? What is the free body diagram?
Reaction section.
P kilonewton per meter. This is A point, this is B point. What are the reactions? What are the reactions at A?
Vertical and
BA, HA, BB. This is L. What is this? This is free body diagram. Right? What are the values you have got? VA किती आला? VA is P into L by 3 and VB is P into L by 6. These are the values you have got. And H is equals to 0. There is no horizontal load. आणि हे पण विचारलं मला, I guess सईने विचारलं की if, see, these are some of the things probably which could be asked in the exam or which will appear and you will have to look at the right. if I give you the inclined load, what you will do? You will resolve it into horizontal and vertical component. Then SFD draw करताना कशाची draw करणार? Horizontal force पण आहे ना, vertical force पण आहे ना. मग SFD दाखवताना sum of forces कुठला घेणार? फक्त vertical. Only vertical. This shows thinking. You should think, then you will get doubts, then you will try to understand why this and why not this. You will answer yourself. So hey, this is also thing you can note. If there is inclined load, what to do? That will get the what will happen if there is inclined load? I have already told you orally, we explain it. So this is then SFD. How is the SFD? Have we done the calculations for SFD? Have we done the calculations for SFD? Tell me. This is A, this is B. Tell me value of shear force at A. How much? Value of shear force at A? Huh? Observations तुमची किती powerful आहेत बघा. Did anybody observe anything powerful in the SFD? In the SFD, did you observe something? Observation, connection, dots. किती दिवसापासून सांगतो तुम्हाला connect the dots. Did you observe one important powerful thing with the SFD? Look at baga. Go through all the SFDs, 2-3 SFDs that you have drawn, and tell me what do you observe with the values. ज्याचा observation and connection of the dots powerful आहे ना, that person will get this. आणि ती इथं पण आहे. Okay, clue is tell me value of shear force at A. हाँ? किती? Plus अरे बोल रहा तो plus PL by 3 and value of B shear force at B minus PL by 6. काय क्ल्यू आहे? कळलं? काय? ये ऑब्जर्वेशन पूछ रहा हूँ. Some important relationship between the shear force diagram. In the shear force diagram, have you observed that? हाँ. Anybody?
At endpoints, value is equal to.
बोलना जोरात.
Is equal to the vertical reaction.
Exactly. The value of shear force at the support is equal to the support reaction. बघा चेक करा आहे का? Support म्हणजे you don't even need to do the calculations. You can tell even without doing this. I can tell what is shear force at A, PL by 3. What is shear force at B, PL by 6. हे तुम्ही बघायला पाहिजे. You have to observe. You did not observe. हा पहिला पार्ट the reaction calculations आहे. तू बघितलाच नाही, तो दिला सोडून. And you just took it to the calculation of shear force. कोण सांगितलं? नाही, मी सांगितलं का? shear force अपवर्ड डाउनवर्ड नाही आहे. क्लॉकवाइज अँटी क्लॉकवाइज shear force साइन कन्व्हेन्शन बघा काय आहे ते. आता इथे सेक्शन घेतला, ऐक, दोन्ही फोर्सेस अपवर्ड आहेत का नाही? ऐका, both the reactions are upward, yes or no? If I take a section here on the right side, the VB is going upward, so is it positive or negative? Negative. Same section on the left side, VA is going upward, positive. Shear force is not upward downward. Similarly, bending moment is not clockwise anti-clockwise. हे सांगून झालेलं आहे. Okay? So, okay, what is the variation? What is the variation? This is PL by 6. This is PL by सांगा variation. Parabolic. Okay. Parabolic variation है ना? So how will I connect it? By the parabola. आणि मला सांगा ओके हाँ चला मी पाणी पितो तोपर्यंत मला सांगा विच ऑफ दीज टू कर्व्स इज करेक्ट. हा सांगा. दोन्ही पॅराबोलिक आहे. बोथ ऑफ देम आर पॅराबोलिक. Then they could be true. Even option 1 could be true, option 2 could be true. I have just connected the two values by a curve. Okay. दोन कर्व मध्ये डिफरन्स काय एवढं सांगू शकता? हे मॅथमॅटिकल ऑब्झर्वेशन्स आहेत. Again, don't do say that we don't get doubts. हे ऑब्झर्वेशन्सच करत नाही तुम्ही. At least can you tell me the difference between the curve number 1 and 2? Curve number 1 is
Shear force is 0.
Opening downwards convex, concave, convex. Have you heard these terms? So curve number 1 is concave downwards and convex upwards. That is true. म्हणजे असा आहे ना तो curve. आणि curve number 2 concave upwards, convex downward. हे कळलंय का? Now tell me which one is the correct? You can't tell. You have not learned how to find that. For that, you need to understand the relationship between.
Point load and distribution load.
You have to understand the relationship between the shear force diagram and loading diagram. This diagram is also called as a loading diagram. या दोन्ही मध्ये रिलेशनशिप आहे. ओके चला रॅन्डम पोल घेऊया. हाऊ मेनी ऑफ यू से कर्व नंबर 1? हाऊ मेनी ऑफ यू से कर्व नंबर 1? Raise your hands clearly. Only 1? 2? Only 1 म्हणते. ही कुठली पद्धत आहे? अच्छा 1 2 असं म्हटलं रे. 2 साठी नाही. 1 साठी हाऊ मेनी ऑफ यू? ये क्या धीरे धीरे क्यों हाथ खड़ा कर रहे हो? ओके 1 2 3 4. 1 2 3 4. ओके बस. आणि फॉर टू अरे रॅन्डम गोष्टींमध्ये सुद्धा फेल आहे. द करेक्ट आन्सर इज नंबर 1. करेक्ट आन्सर इज नंबर 1. Correct answer is number 2. Yes, correct answer is number 2. Upward correct. There is a hard Is it okay now? Is it okay? 2 is the correct answer. दोन्ही ड्रॉ करा. Draw both the curves and show the correct one. एक मिनिट द्या मला परत. Quick. Can you tell me another observation about the number 2 and number 1? सांगता येईल? Yes, very good. नियम सांग काय म्हणतो?
स्लोप डिक्रीजिंग आहे.
कशाचा?
तो सेकंड
1 चा की 2 चा?
सेकंड.
दोन्हीचे स्लोप डिक्रीजिंगच आहे.
But
the rate of decrease of slope is different. हाँ काय तेच आहे. ऐका इकडे बघा इकडे बघा इकडे बघा प्लीज इकडे बघा कर्व नंबर 1 ला ऑब्झर्व करा कर्व नंबर 1 हा मी व्यवस्थित ड्रॉ केलेला नाही आहे तो कसा आहे माहिती का ऍक्च्युली दिस इज द लाईन दिस इज लाईन ए ला कर्व कसा आहे तो इकडे बघा व्यवस्थित बघा इज व्हेरी मच इम्पॉर्टंट तो कर्व असा आहे डू अंडरस्टँड दिस
Yes.
if at point A हा जो काही पॉइंट आहे तो if I want to draw the tangent to the curve कसा येणार तो माहिती आहे हॉरिझॉन्टल आणि at point B ला तो कर्व कसा आहे इकडे बघा this is your point and tangent to this curve at point B how it will be yes or no this is about curve 1 and if I try to do the same for curve 2 how it is curve 2 बघा उल्टा आहे do you understand this बघा if I want to draw the tangent at point B to the curve how that will be it will be horizontal and at point A the tangent will be at least can you tell me at which point the curves 1 and 2 have got more slope and lesser slope फर्स्ट मध्ये कुठे स्लोप जास्त आहे बी ला एक्झॅक्टली आणि सेकंड मध्ये ए ला हा डिफरन्स आहे कॅन यू रिलेट दिस डायग्राम टू दिस डायग्राम स्पेसिफिकली लोडिंग डायग्राम दॅट इज द रिलेशनशिप बिटवीन द शिअर फोर्स अँड लोडिंग डायग्राम सांगता येईल 3 गोष्टी दिलेल्या आहेत तुम्हाला SFD values are same I have given you 2 curves of variation this is one curve of shear force this is second curve of shear force and this is the loading diagram what is your observation shear force curve in curve number 1 has 0 slope at A and maximum slope at A in 2 इथे किती आहे maximum slope at B and 0 slope at B can you connect this 0 slope and maximum slope to the loading diagram काय आहे
maximum slope represents maximum loading.
Exactly. The relationship between shear force and loading diagram is that the slope of shear force diagram at a point is nothing but loading intensity at that point. Now, where in the load, where on the beam the load is maximum? A la? Yes or no? Look at the slopes. Where in these 2 diagrams the slope is maximum at A? 2. 1 la ki 2 la? 2 la. So one thing got confirmed. What is the value of loading at B? Value of loading at B किती है? 0. Where in this diagram the value of slope is 0? Whether in 1 or 2?
2.
So that is why this 2 is correct. That is why the shape of the shear force diagram 2 is correct. Got this? लिहून घेतलंय. ड्रॉ करा पुढे रिलेशनशिप्स काढून कर्व काढून दाखवणार आहे तुम्हाला अजून. सेम थिंग आय एम गोइंग टू गिव्ह यू.
त्याच्या बेसिसवर आपण
त्याच्या बेसिसवर काढलं की we just know that it is a parabolic curve, so there are 2 parabolic curves possible connecting A to B point. एक असा कर्व पॉसिबल आहे, एक असा कर्व पॉसिबल आहे, बट करेक्ट कुठला? सेकंड वन, दिस वन. काय इक्वेशन काढलेलं नाहीये? रीड करा. रीड द इक्वेशन ऑफ शेअर फोर्स. रीड करा पटकन. किती आहे शेअर फोर्स इक्वेशन? किती बाय सांग? माइनस PL/6 प्लस
px square by 12.
px square by 12. मग x square आहे ना, पॅराबोलाचं इक्वेशन. x स्क्वेअर आहे म्हणजे डिग्री 2 झालं की बस क्वाड्रेटिक आहे. So you want to connect the point this and this with the parabolic curve. So either you can draw like this or draw like this. So I have drawn both the options. But out of these two, which one is correct? Number 2 is correct. I just explained the reason. Chala, bending moment calculations quickly. Chala, bending moment calculations. हे त्याच्यात हे येते का? हे येते का? ही साईड येते?
हो येते.
चला bending moment calculations. चला पटकन करा. Because in this problem you understand the relationship between three things: loading diagram, shear force diagram, and bending moment diagram. So you are supposed to be aware. You are going to focus, note the thing, and relate the two things. मी तुम्हाला सांगितलं, connect the loading diagram to the shear force diagram to this curve. Same we are going to do with the bending moment. So bending moment calculations, when we write, what is the first thing that we are going to write? Sign convention. Sign convention काय आहे सांगा? Sagging positive, hogging negative. How do we show the sagging?
Upwards.
This is sagging. And hogging is? Chala. Hold it up. So we have already considered a section. Where is the section? This is our section. At what distance? X from B. चला मला कोण उत्तर देईल? What is the distance between section XX and point B?
X.
X. I will say, my name is Rohit. Can you tell me what is my name? I have considered a section at distance x from B. What is the distance of section XX from B? Give it, sir. Right? So it is x distance, right? So can we write the equation of bending moment at XX directly? Let us write this. So bending moment at section XX is equal to. What is the bending moment again? Sum of moments
on
either on left or right. Where we are looking at this point? Right side. So let us look at the right side of the section. This is your x-axis. Right side la काय है? You take the moment of the forces. How many forces are there?
2.
2. One is VB and other is this
UVL.
UVL, triangular road. First, can you write the moment of this VB?
Yes.
What is moment? Force into perpendicular distance. What is the force? PL by 6 or VB. What is the perpendicular distance between the section and this force? X. Right? Gita here?
Yes.
VB into X. Yes or no? Can you tell me whether it is sagging or hogging? VB is causing what type of moment at X-axis? Sagging or hogging? Sagging. Because on the right side it is trying to take the beam upwards. That's why it is. So plus sign. Okay. Little bit complicated one. Next part. So त्यासाठी मी परत एकदा तो the small diagram I am going to draw again. So this is your section X. This is your UVL. What is this distance? X. This is point B. एवढा आहे? Yes or no? I want to take the moment of this load at section XX. What is moment again? Tell me. What is moment? Force into perpendicular distance. So what is the total force of this? What is the total force of this UVL? How to find that out? Area. So total force is equals to half into, let us say this height is काय म्हणतो त्याला आपण? WX. Let us call it as WX. So area of the triangle is half into WX into X. Yes or no? That is the total force. How do we consider the total force to be acting at what location? हा total force आहे ना? Where do we consider it to be acting when we take the moment? CG or centroid? So हा सगळा force कुठे assume करणार आपण? We assume that it is acting at what?
1 by 3 of x.
Half WX into X. Where it is acting?
1 by
At CG. What is the distance of CG from XX? किती डिस्टन्स आहे? What is this distance? Tell me.
x by 3.
X by, and what is this distance?
2x by 3.
2x by 3. Can you write the moment equation for this now? Bending moment. Tell me. Now tell me what is the bending moment of this UVL at section XX. हा तुमचा section XX आहे. This is your section XX. Tell me the bending moment of this at section XX now. हाँ. Bending moment is sum of moments of the एक force दिला है. What is the remaining force? UVL. What is the moment of this UVL at point XX? सांगा. काय लिहिते? प्लस साइन राहू दे. पहिला तुम्ही मॅग्निट्यूड सांगा. पहिला फोर्स सांगा. टोटल फोर्स इज दिस नो R into WX into X. Yes or no? That is the total force. Total force on right of section. Yes or no? And multiplied by what? Perpendicular distance between the two. Total distance get x by 3 or 2x by 3?
X by
Which distance will you take?
X by 3.
Because you are taking moment at this point, so centroid distance काय झालं? X by 3. So that is your correct distance. हे कसलं distance आहे? Distance of centroid of loading area from कुठून आहे distance? XX. B नाही, XX पासून. बरं, याचं साइन काय येणार?
Minus.
Why negative?
Downwards.
Why hogging?
Downwards.
Why hogging? Because on the right side of the section, the load is trying to take the beam downward. That's why. चलो solve करा. Give me the equation. Give me the equation. So this is complete equation now. Solve it means just give me the simplified form. So what does it give you? Is equal to BB किती आहे? PL by 6. PL by 6 into X minus half. What is value of WX? आता हे find out केलं आपण. WX किती आहे? What is value of WX?
X by
L ला P, X ला किती? PX by L. That is PX by L. So put this half into Px by L into X by 3. Yes or no? Look at this. What do you get? You get PL by 6 PLX by 3 minus PX cube by 6L. Did you get this? What you are getting? You are getting the power of X as. So the bending moment equation, what you are getting? TLX by 6 minus PX cube by 6L. Yes or no? What does this mean? The curve of bending moment diagram is what? Cubic curve. That it is a cubic curve. आता एक तुम्हाला म्हणजे सांगतो, हा मला प्रिय म्हटला सर कसं कळलं तू पॅराबोलिक आहे क्यूबिक कसं ड्रॉ करायचा? क्यूबिक म्हणजे कर्वच आहे. तू यू डोंट हॅव टू यूज द ग्राफ. कळलं का? आता हा कुठला कर्व आहे सांगा? 2 डिग्री का 3 डिग्री का 4 डिग्री? यू कांट टेल. यू कांट टेल. वी जस्ट आर गोइंग टू मेक यूज ऑफ दिस. डिग्री 3 म्हणजे डिग्री 3 कर्व आहे आणि तुम्ही लिहिणार मी 3 डिग्री झाला. गॉट दिस? सो यू डोंट हॅव टू बॉदर अबाउट सर इथं काय व्हॅल्यू येते हे काय कर्व ड्रॉ करायचा फक्त. हो कसं पण नाही, हे नियम आहेत ना. बाय टेकिंग केअर ऑफ दीज रूल्स यू हॅव टू ड्रॉ द कर्व. सो कळलेलं आहे क्यूबिक कर्व आहे. चला आता ड्रॉ करूयात. क्यूबिक कर्व ड्रॉ करूया. बिफोर दॅट वी नीड टू नो द व्हॅल्यूज ऑफ बेंडिंग मोमेंट ॲट ए अँड बी. कॅल्क्युलेट करा. चला ॲट ए. सो ॲट ए. At A, x is equals to how much? X is equals to L. So, bending moment at A is equals to, सांगा.
0.
Value put करून बघा. 0. Value is eventually going to, हे put करून बघा. It is going to be 0. At B, x is equals to 0. So, bending moment at B, 0 0 0 काय करायचं सर काय हॉरिझॉन्टल लाईन आहे का झिरो लाईन आहे का नो काय करणार मग आता एक क्ल्यू देतो हा प्रॉब्लेम थोडा डिफरंट आहे UVL इज द हायेस्ट डिफिकल्ट लेवल दॅट यू कॅन गेट UVL there is a relationship between shear force and bending moment that you will have to use लिहा त्याच्यामध्ये the section at which write down the section at which shear force is 0 bending moment is maximum a rule आहे the section at which the shear force is 0 bending moment is maximum आता काढू शकता कॅन यू डू दॅट नाउ काय करणार आता फर्स्ट फाइंड आउट द सेक्शन ॲट विच द शेअर फोर्स इज 0 हाऊ टू फाइंड आउट द सेक्शन ॲट विच द शेअर फोर्स इज 0 म्हणजे काय फाइंड आउट करणार एक्स डिस्टन्स ॲट विच द शेअर फोर्स इज 0 शेअर फोर्स इज 0 म्हणजे कुठलं इक्वेशन वापरणार शेअर फोर्स इक्वेशन काय आहे शेअर फोर्स इक्वेशन देअरफॉर काय आहे So, the section at which shear force is 0. सांगा इक्वेशन काय शेअर फोर्सचं शेअर फोर्सचं इक्वेशन काय बनू मायनस PL बाय 6 प्लस PL x स्क्वेअर बरोबर आहे का px स्क्वेअर एल नाही आहे सो दिस इज शेअर फोर्स व्हॅल्यू ॲट x6 येस और नो एकदा क्लिअर सांगा ना कुणीतरी हे मग px स्क्वेअर बाय 2 लिहिलंय हां झालं हे काय करायला पाहिजे आपल्याला 0 करायला पाहिजे सो दिस इज इक्वल्स टू 0 सो यू विल गेट मायनस PL बाय 6 plus px square by 2l. Find out the value of x.
L by 2.
L by 2 नाही रे. किती काढलं बघ किती काढलं L by √3 म्हणजे किती आलं बघा किती डिस्टन्स आला एक्झॅक्ट डेसिमल मध्ये सांगा पटकन हा काय 0.57 सो तुम्हाला कळतंय का कॅन यू सी इन द शेअर फोर्स डायग्राम देयर इज अ पॉइंट वेअर शेअर फोर्स इज 0 दिसतंय काय सगळ्यांना हा पॉइंट हा दिस इज द पॉइंट वेअर द शेअर फोर्स इज 0 अँड व्हॉट इज दिस डिस्टन्स L by √3 आणि काय नियम लिहून दिला तुम्हाला मी आता what did I give you just now the maximum bending moment in the beam with the UVL acts where the shear force is 0 कळलं का सो तुम्हाला A ला शेअर बेंडिंग मोमेंट 0 आहे B ला बेंडिंग मोमेंट 0 आहे कॅन यू कॅल्क्युलेट द बेंडिंग मोमेंट ॲट x इज इक्वल्स टू L by √3 कॅल्क्युलेट करा सो ॲट x is equals to L by √3 bending moment is equal to what is our equation of bending moment PL x by 6 minus PX cube by 6 है PL x की वैल्यू कितनी है L by √3 PL into L by √3 by 6 minus P into L by √3 bracket cube divided by 6 चला सॉल्व करा गिव द व्हॅल्यू ऑफ बेंडिंग मोमेंट हां
सर आपण शेअर फोर्स मध्ये x a पासून काउंट केला
बघ बघ हां
हे कसं म्हणजे कुठून आलं सर रिझल्ट
काय
शेअर फोर्स इज 0 आहे वेअर बेंडिंग मोमेंट इज मॅक्सिमम
हां
वेअर टू वी गेट
ते शिकायचं अजून ते पुढे अजून शिकवायचं येतात ते सांगितल्याशिवाय BMD ड्रॉच करता येतं त्यामुळे सांगितलं हां
नाही बट सर बेंडिंग मोमेंटची इक्वेशन वरून मॅक्सिमम काढू शकतो बेंडिंग
अवघड डिफरन्शिएट करून बसायला पाहिजे
मॅक्सिमम
हां मिळालं व्हॅल्यू? हॅज एनिबडी गॉट द व्हॅल्यू सम सिम्प्लिफाईड फॉर्म? व्हॉट इज दॅट? पटकन सांगा. अरे एक तास केला. हॉरिबल आहे. हां 0.55 PL स्क्वेअर. काय आन्सर? डेसिमल होतो इकडे याच्यामध्ये रेशोमध्ये सांगा. PL स्क्वेअर बाय 9√2. PL स्क्वेअर बाय 9. ओके चला. व्हॉट अबाउट द शेप ऑफ द BMD? लेट अस ड्रॉ द शेप ऑफ द BMD. This is your SFD. This is your BMD. Chalo, tell me what is the value of bending moment at A? 0. What is the value of bending moment at B? 0. What is the maximum value of bending moment and where it is occurring? At distance L by √3 from B. किती आहे ती व्हॅल्यू? ही व्हॅल्यू किती आहे? PL square by 9. How to connect the curve?
सर स्लोप डिक्रीजिंग पाहिजे.
हा पॅराबोला नाही आहे म्हणून तुम्हाला डिग्री कर्व लिहायची सवय का लावलेली आहे? हा पॅराबोला नाही आहे. हा 3 डिग्री कर्व आहे. हा 3 डिग्री कर्व आहे. And one important observation. What is that? What is that observation? Look at this. Yes. काय सांग रोहन? कुठे? At this distance, slope of bending moment diagram is 0. So slope of bending moment diagram at the point is equals to shear force. Slope of shear force diagram is equals to load at that point. उलटे करू शकता?
Area under
Yes. Very good. Very good. Area under curve between the 2 points in loading diagram is the shear force. Area under curve between 2 points in the shear force diagram is bending moment. लिहून देणार असेल. Don't इथे बघा again. Slope of bending moment diagram at this point is how much? 0. Horizontal आहे ना नाही? Tangent slope म्हणजे slope of curve, no? So that line is horizontal. So slope of bending moment diagram at this point is 0. So shear force at that point is 0. So slope of bending moment diagram is nothing but shear force at that point. And slope of shear force diagram at that point is equals to value of loading at that point. Got this? Got this? A 3 degree curve hai. So this is your positive BMD. This is your positive BMD. So, Patkan, you are going to take numerical. First numerical here. Draw the SFD and BMD for. Draw the SFD and BMD for B shown. I will describe the beam. मी ड्रॉ करताना तुम्ही पण ड्रॉ करा. Simply supported beam घ्या. Simply supported beam. Left end hinge, right end roller. Draw the SFD and BMD for the beam shown in figure. Left end hinge, call it as A. Right end roller support, call it as a B. Now I'm going to give you the loading. I'm going to give you the loading. Okay. थोडं जाऊ का? एक स्टेप आहे जाऊ का सिंपल प्रॉब्लेमचा? ठीक आहे, राहू दे. लेट अस सॉल्व दिस प्रॉब्लेम. सो हे सगळे प्रोजेक्शन्स खाली घ्या. ऑल these projections आउट. Okay. So this is your given beam. चलो we are going to start solving this problem. ज्यांना माहिती आहे reactions find out करता येतात, SFD काढता येते, quickly start solving it. So the beam is in equilibrium. The beam is in equilibrium. The beam is in equilibrium. So first part remove करू झाले लिहून. So we'll have to draw the FBD of this. These are the x-axis, y-axis. So this is 20 km point load. This is 10 km point load. So the reactions and the supports are VA, vertical at each support, HA, horizontal at each support A. This is point B. So there is a vertical reaction at roller support B, VB, and the distances are 1 meter, 1 meter, 1 meter. Okay. So this is your FBD, free body diagram of the beam. This is your free body diagram of the beam. Okay. The next is we are going to find out the reactions. Reactions find out करते हैं विशाखा. Reactions. Reactions find out करते हैं ना बात. Beam equilibrium मध्ये आहे. Beam equilibrium मध्ये आहे. The beam is in equilibrium. So which are the equations you will use? First part is to find out the support reaction. इथे लिहा रे बाळगो. तुम्ही लिहिताना चूक केला तर बघे. थँक गॉड तर तुम्ही भेटताय काही काही जण म्हणून कळतंय. हे बोर्डवर जसे लिहिलंय तसं तुम्ही त्याच्यात 4 भाग केलेत काय जण नाही लिहिले. 3च. I had asked you to prepare 3 columns only ना. 3 columns. First column is this. Second column is the diagram. And third column is all the calculations. तुम्ही लिहिताना सुद्धा व्यवस्थित लिहा. So next time when you are revising, you should read it step by step. So step 1 असं म्हणा त्याला. Step 1. What is the step 1? Find support reactions. Support reactions. The beam is in equilibrium. So how many equations of equilibrium you can use? 3. Summation Fx is equals to 0. Rightward force if I take positive. ये applicable है ना? हाँ तो Fx equals to 0 equation क्या आएगा? Fx मतलब forces in x direction. हाँ बताओ कौन से forces x direction? H yes. Plus लिखो H को Q. It is rightward. So H or there is no other force. So क्या लिखो? 0. H is equals to right. Okay. Then summation Fy बताओ. Upward positive अगर लिखो तो क्या लिखोगे? -20. Okay. -10. Okay. VA की reaction से नहीं ये भी reaction. हाँ क्या लिखोगे? Plus VA plus VB is equals to 0. So what do you get? VA plus VB is equals to 30. और this is the question number 1. Moment का equation बता सकते हो? Summation of moment at A is equals to 0 if I consider clockwise positive. Can you tell how to take the moment at A? हाँ बताओ. क्या लिखोगे? VA into कहाँ भी moment लेना है? We are taking moment at this point, huh? So moment of HA will be HA is passing through that point only. So moment of HA will be 0. VA का मोमेंट कितना होगा ये? ये पॉइंट यहाँ पे दिस इज लेटर से 10 और ये डिस्टेंस है 2. What is the moment of this 10 at this point? 10 into 2. If I draw a force on here 20, what is the moment of this 20 at this point? So because the distance is 0. So what is the moment of VA at this point? So what is the moment of 20 at this point? 20 into 1. So it is 20 into 1 plus or minus clockwise. 10 का बताओ? 10 into yes. 10 into 2 plus or minus q plus clockwise positive है. On this end 10 is causing the clockwise moment. I have considered clockwise positive and remaining minus VB into is equal to 0. What is the value of VB? 15 है कितने ना? 13.3 किलो न्यूटन जर लिहिलं नसेल थोडा तो हा तुझे मार्क कर पृथ्वीचे मार्क्स करतील ना किलो न्यूटन नव्हतं you'll have to write this. So from equation 1 VA is how much? 16.67 kilonewton. चला let us start drawing the SFD shear force calculations. काय बरोबर आहे रे 26 कोण म्हणतो रे VA 26 VA 26 आहे. So shear force step 2 is what? Shear force calculations. Shear force calculation तो sign convention काय आहे? This is positive. These are the sign conventions for the shear force. आता काय करणार? You will have to consider the parts. Call this as the part point C, call this as the point D, call this as point C. So, consider a section XX at distance x from A or B, any. So, write down that. Consider section XX at distance x from A. So, let us show the section. So this is your section XX at distance x, right? Okay. So shear force at for part AC. For part AC. What is the equation of shear force? Tell me. You can tell me. चला कौन सा? तू सांग मला. Shear force section of equation of shear force in section AC सांग. AC मध्ये प्लस मायनस साइन साइन सांगायचं हा प्लस VA आणि झालं एवढंच आहे. Yes. So that is what is the meaning of this? Constant value of shear force. Yes or no? Constant value of shear force. So can we calculate the shear force at A and shear force at C? Yes. So at A, x is equals to 0. So shear force at A is equals to plus VA is equals to how much? VA किती? 13.33. 13.3 kilo. VA किती? Sorry, 16.6. At C, x is equals to 1 meter. Doesn't matter. Shear force at C is equals to plus 16.6. चलो एवढे ड्रॉ करू शकतो आपण. Can we draw this much part? So what is the value of shear force at A? 16.66. 16.66. What is the value of shear force at C? 16.66. So this is 16.66. This is point A. This is point B, C. Okay. So we have drawn it till this point. Chalo. For part CD. For part CD. For part CD, what is the equation? कौन सा करता? Who is going to tell me? So the section is over here now. The section is in CD part. X at distance x from कौन सा? कौन सा? बाजू सा? हाँ. CD ला काय सांगायचं सांग होतं. अरे CD मध्ये सेक्शन x ला शेअर फोर्स इक्वेशन सांगू शकशील का नाही? नाही. प्रेम तू सांग मला. सेक्शन x ला शेअर फोर्स इक्वेशन VA minus x. प्रेम काय बरं? 20. तो परत सांग with sign सांग. Every value with sign. VA चं sign काय? Plus VA minus 20. Is it correct?
Yes.
Absolutely. So it is plus VA. आता ज्यांनी कोणी प्रॉम्प्ट केला असेल तर त्याला घरी जाऊन कानाखाली मार. घरी जाऊन नाही, क्लास संपला. If he has helped you, he has got you into trouble. तुला स्वतः सांगता आलं असलं तर बरोबर आहे. Plus VA minus 20. So काय आली व्हॅल्यू?
3.3 minus.
Plus 16.6 minus 20 is equal to साइन साइड सांग रे. Minus 3.3 kilonewton with unit. And what does this mean? Constant again? Yes or no? It is constant. Chala, find out the values of shear force at C and D. So at C, x is equals to how much? 1 meter. Doesn't matter. So shear force at C is equals to minus 3.3 kilonewton. At D, x is equals to 2 meter. Shear force at D is equals to minus 3. Shear force च्या जागी S लिहिलं फक्त SF or S. So, sorry, इथं चुकीची नाव होती. This is C, D. So what is बघा? Now shear force at C has got two values. First value was 16.66. Yes or no? See. This one, and next value is minus 3.33. Minus 3.33. तो कसा आहे ना? So shear force at C is minus 3.33. This is 3.33. And what is shear force at D? Minus 3.33. So this is minus. This is plus. So at C you have got two values. At C, this is your point C. You have got two values. First value is positive 16.66. Another value is negative 3.33. Right? Let us go further. So it is come to mini calculation. So for part DB. For part DB, shear force at section XX is equal to, who can tell me quickly? कुठे घेणार सेक्शन कुठे घेणार? D आणि B च्या मध्ये. बरोबर. हा आहे तुमचा सेक्शन XX. किती डिस्टन्स वर घेणार बा? X कुठून? A पासून. बरोबर. हा तर या सेक्शनला सांग बरं इक्वेशन. With sign, every value should be told with sign. Plus VA minus 20 minus 10. म्हणजे किती आलं याचा आन्सर सांगा?
minus 45.
मायनस तुम्हाला दिसतंय का बघा काय वाटलं काय? हीच व्हॅल्यू यायला पाहिजे. रिमेंबर दिस इज अ चेक. 13.33 is nothing but the reaction at the end B. If the reaction at end B is 13.33, what is the shear force at end B? 13.33. This is a check. If this check is not being satisfied, you are doing some mistake. Got this? So minus 13.3. So you can write at dx is equals to 2 meter. Doesn't matter. Shear force at d is equals to minus 13.33. At dx is equals to 3 meter. Shear force at B is equals to, doesn't matter, minus 13.33. The distance doesn't matter. What does this mean? This is again a constant value. That is constant. Constant. So how will be the shear force diagram? So at D you have got another value 13.33. This is 3.33. This is 13.3. This is constant. This is 13. This is negative. So your shear force diagram is like this. You have to write that it is the shear force. Look at this shear force diagram, and in bracket mention that it is in kilonewton, and also show the distances 1 meter, 1 meter, 1 meter. Very much important. This is your shear force diagram. This is your shear force diagram. BMD complete करून जाणार होता. चला बेंडिंग मोमेंट करा. सिंपल आहे. This is the simplest problem that you can get. करा बरं. कोणी केलेलं आहे? केलंच बा? Very good. 2 people have done it. 3 people have done it. 4 people have done it. Very good. Very good. दाखवा बरं मला. तुम्ही यावर ड्रॉ करून इथे दाखवा. दाखवा तुमचं बीम ड्रॉ करा. हां अजून विषय. हां कर ना कर. तिथे टॉपला कर. तिथे टॉपला ड्रॉ. चला बेंडिंग मोमेंट कॅल्क्युलेशन्स. Let us check Vishwajit's काय diagram. This is the SFD. Let us check BMD. झालं ना? करेक्ट. चला बेंडिंग मोमेंट कॅल्क्युलेशन स्टेप 3. बेंडिंग मोमेंट calculations. So what are the sign convention? Sagging, positive, and hogging, negative. Chalo. So the sections are already defined. So we are going to part by part. First, which part we have to consider? AC. So for part AC. कुठे आहे हा AC part? This is the AC part. We have taken the section is AC part, no? AC part. AC part चे पुढे बघणार आपण left side ला. What is bending moment? Bending moment is sum of moments on left or right. So left ला how many forces are there? 2. HA and VA. What is the moment of HA at XX? 0. And because that HA is passing through this, and HA is also 0. What is the moment of VA at XX? What is the moment of VA at this section XX? VA into X, sagging or hogging? Because it is going upwards. No? VA into X is the only bending moment. So, bending moment at section XX is equals to plus VA into X. VA into X, VA किती आहे? Plus 16.66x. What does it tell you? Variation कसा है? Linear. Variation is linear. Variation is linear. Variation is linear. Can we find out the values at A and C? So at A ला किती असणार आहे बेंडिंग मोमेंट सांगा? 0. You don't have to calculate. You will have to confirm. With this equation, you will have to confirm. बराबर है? So at A, x is equals to 0. Look at this. So bending moment at A is equals to 0. Put the value of x is equals to 0. So at C, x is equals to how much? 1 meter. Yes or no? Now put the value of 1 meter in the bending moments equation. किती आहे ते? So bending moment at C is equals to plus 16.66 into 1 meter. What is the value you are getting? What is the unit of bending moment? 16.66 kilo Newton meter positive. This is the value of bending. Can we plot this? Chala. Let us plot this. Let us plot this. Let's try to plot this. So, what is the bending moment at A? What is the bending moment at A? 0. What is the bending moment at C? 16.6. How is the variation?
Linear.
And this is positive. This value is 16.66. Variation is linear. You have just connected it to the line. Chala, next. Complete the right. So bending for part CD. Bending moment at xx is equal to सांगा कोणी सांगते? Plus BA into x minus 20 into a सांगा हे कोण सांगते? 20 into काय येणार? Now the section is here. 20 into मानू कळलं काय? How many of you have got this?
X minus 1.
what कळलं? कळलं की नाही? सगळ्यांना विचार. But raise your hands. How many of you have got the bending moment of 20 at xx? किती जणांना कळलं? Raise your hands clearly. How many of you have not got this? Bending moment of बस तरी रे बस. Bending moment of 20 km at xx कुठला येणार? Here you are taking the moment, no? Moment of 20 at xx किती येणार? 20 multiplied by which distance? This distance. This distance किती आहे सांगा?
X
The
minus
total distance is x and this distance is 1. So x minus 1, you will get x minus 1 distance. So what is the distance? X minus 1. What is the bending moment? 20 into x minus 1. Why negative? Why negative? Because it is a hogging bending moment. Do you see this or not? See at this section, 20 kilometer is going downward, no? But it is trying to bend the beam downwards. So that is why it is hogging. Only minus. Okay, next. Is that? Yes. So what does this mean? Again, the variation is linear. X power 1, so variation is linear. X power is 1, variation is linear. So I'll find out the value at C. X is equals to 1 meter. Yes or no? So put the value in this equation. Therefore bending moment at C is equals to B into x is how much? 16.66 minus 20 into 1 minus 1. That is equals to plus 16.66 kilonewton meter. At B, x is equals to 2 meter. Put the value of 2 meter into the other equation. 16.66 x into 1 side into 2 minus 20 into 2 minus 1. What is the bending moment at D? Bending moment at D किती आला? 13.34. Positive or negative? 13.34 kilonewton. Done. Let us do it. Okay, let us plot it. Plot for that. What is the bending moment at C? C like the bending moment 16.66. So it is confirmed C. Earlier you got the plus 16.66. Now also you got plus 16.66. So bending moment value at a section remains same whether you take AC section, CD section. There is an exception for this. Then same value. Okay. D like the bending moment 13.33. So this value is somewhere over here. So I'll connect it like this. 13. 0 का आलंय? तू कॅल्क्युलेट करून सांगायलास का तुझा अंदाज सांगायला? कॅल्क्युलेट करताना काय व्हॅल्यू घेतलंस बघ. डिजिट डेसिमलचा 0च यायला पाहिजे. ओके 13.3. चला लास्ट करा. फॉर पार्ट BB बेंडिंग मोमेंट ॲट सेक्शन एक्स कोण सांगणार आहे का? हां बताओ.
plus VA into x
येस
minus 20 into x minus
20 इंटू
x minus
एक्स मायनस
1.
1 ही आहे का? जे दमलेले आहेत, जे कंटाळलेले आहेत, त्यांनी जर आता लक्ष नाही दिलं तर तुम्ही चुका करत राहा.
20 into x
20 इंटू
x minus 1
एक्स मायनस 1 ही आहे का?
minus
मायनस
10 into x minus 2.
येस. हे घरी जाऊन आज रिवाइज करायचं. हाऊ इज दिस एक्स मायनस 1 एक्स मायनस 2 यू आर गोइंग टू गेट दिस डिस्टन्स. सो व्हॉट इज द व्हेरिएशन? व्हॉट इज द व्हेरिएशन? लिनियर अगेन. दॅट इज लिनियर. चला. So find out the values at D x is equals to how much? 2 meters. Put the value in this equation. बाहेर तुम्ही करता ना हे? प्रथमेश करतोस का? या इक्वेशन मध्ये x ची व्हॅल्यू 2 मीटर टाका. व्हॉट डू यू गेट? सो बेंडिंग मोमेंट at D is equals to VA into x is there 16.66 into 2 minus 20 into 2 minus 1 minus 10 into 2 minus 2. किती आहे ना व्हॅल्यू ही? किती यायला पाहिजे? 13.33 यायलाच पाहिजे. सो प्लस 13.33. Then at B x is equals to 3 meters. So bending moment at D is equal to 16.66 into 3 minus 20 into 3 minus 1 minus 10 into 3 minus 2. What is the value? 0. Yeah. This is your bending moment diagram. This value is 13.33. Yeah? This value is 13.33. This value is 16.66. So this is your BMD. What is the unit? Unit काय आहे? Kilometer meter. And what are the distances? 1 meter, 1 meter, 1 meter. Okay. आणि variation कसा आहे? Linear. Everywhere the variation is linear. This one. So this is the complete SFD and BMD of the 2 point loads at given distance. आता याचे प्रॉब्लेम सॉल्व करायला स्टार्ट करायचं. Today you are going to solve one more problem of this. Okay? आणि आय एम गोइंग टू गिव्ह यू समथिंग डिफरंट. काय करायचं? हा प्रॉब्लेम सॉल्व करा. व्हॉट यू आर गोइंग टू डू? सॉल्व दिस प्रॉब्लेम. हे माझ्या इकडे बघा. हा प्रॉब्लेम आजच्या सॉल्व करून टाकायचा. चला हा प्रॉब्लेम सॉल्व करू. Okay, so I am breaking the stereotype in the second step of the numerical itself. जो लोड आहे तो प्रत्येक वेळेला डाउनवर्डच असेल असं नाहीये. अपवर्ड लोड दिलेला आहे. सॉल्व दॅट प्रॉब्लेम. अरे जाऊ असं यू थिंक अरे